Students, welcome to my class. In my today's session, we will see another pattern of a problem that we have under sensitivity analysis. We know sensitivity analysis is basically an analysis that finds how sensitive an outcome is to any change in the variables which are its inputs. So if we have input variables in a capital budgeting decision like the discount rate, the cash flows, the growth rate, how does it affect the NPV or maybe the IRR is what we're going to understand in the sensitivity analysis. And we also know that the project's NPV and IRR can be computed under the three assumptions. One is under the optimistic or say the best outcome situation. Another one is the expected or say the normal or the most likely situation. The last one is a pessimistic or the worst outcome situation. One of the main advantages of this method is that it identifies the critical values, the critical variables for which special actions can be taken. Alright, so we will just see what kind of question is this, and then we will see how solution can be offered to this. The question is like this: Ankur Industries has identified that the following factors with the respective expected values have a bearing on the NPV of their new project. Ankur Industries have actually identified that there are various factors which have a bearing on the NPV of their new output or the project. So we should see what kind of data is this. They've given us the initial investment, then the cost of capital, which is the otherwise the interest factor, the discount factor, all of them. Quantity that's manufactured and sold is also given to us. Price per unit, variable cost per unit, fixed costs, depreciation, tax rate, life of the project, which is 7 years, net salvage value is given to us. We need to assume that the following underlying variables can take the values as shown below. And they've given us the underlying variable as two situations offered here are two, pessimistic and optimistic. Quantity manufactured and sold is 700 and 1400. I've asked you to calculate the sensitivity of the net present value to the variations in quantity manufactured and sold. And the PVIF, that is the annuity value for 7 years at the rate of 11% is given to us, which is 4.71. Yeah. So we'll see what the solution can be arrived at here. The problem over here is to calculate the sensitivity analysis, sensitivity of the NPV, sensitivity of the NPV value to the variations of the quantity manufactured and the sold. Okay. So we can just take up sensitivity analysis this way. I've taken the initial investment. First of all, since sensitivity analysis has to be worked out in three different situations, namely the pessimistic, expected and the optimistic, I've taken those values. Let me color it. I'll just shade it otherwise. Yeah. The initial investment is given to us, which is otherwise the cash outlay. I've just taken it as it is 10,000, 10,000, 10,000. Why this is important? Because NPV has to be calculated. And we know NPV is equal to PVCIF minus PVCOF. And PVCOF is this initial investment or the cash outlay. So we need to keep it aside. I've just taken the values as it is. And since the information is given to us, that is the units, and the units are given to us as 1000, I've taken for the expected or the normal situation, the total quantity manufactured and sold is 1000, while they have given you under the pessimistic situation it is 700 and optimistic situation is 1400. So I've taken those values as it is, 700, 1000 and 1400. This initial investment is not going to change in any ways. Okay. So let's go to the variables that can help us to actually arrive at the cash flows after taxation but before depreciation. So yes, sales is 14, 20, 28. How did we get this? It is 700 multiplied with 20. Yeah. So 1000 multiplied with 20 is 20,000. 1400 multiplied with 20, which is 28,000. Minus all the operating expenses. Okay. So we have the variable costs here. Variable cost is 15 per unit. So I've taken what? 15 into 700, 15 into 1000, 15 into 1400. Less fixed cost, that is going to remain constant. So I've just taken it as it is. That's given to us in the question here. So minus fixed cost, minus depreciation, which is 1000, 1000 and 1000. So what is profit before tax? Profit before tax is after deducting the variable cost, the fixed cost and the depreciation. So we have 14,000 minus all these, okay, 14,000 minus all this, that is 1,500, 20,000 minus all this, 3,000, and 28,000 minus all this, 5,000. And now we have to deduct the tax, which is at the rate of 20%. So 20% of 1,500 is 300, 20% of 3,000 is 600, 20% of 5,000 is 1,000. So profit after taxation is 1500 minus 300, 1,200, 3,000 minus 600, which is 2,400, 5,000 minus 1,000, which is 4,000. So how did I get this the cash flows here, the net cash flows? It is after adding up the depreciation. So we know the depreciation is 1,000, 1,200 plus 1,000 is 2,200, 2,400 plus 1,000 is 3,400, then 4,000 plus 1,000 is 5,000. PVCIF, we know PVCIF will be determined using the formula net cash flows multiplied with discount factor. So what is a discount factor here? Discount factor for 11% for 7 years is given to you as 4.712. So what I have done is I've taken 2,200 into 4.712. So we got 10,366. 3,400 multiplied with 4.712 is 16,020, and 5,000 multiplied with 4.712 is 23,560. So how did we get the NPV? NPV is equal to PVCIF minus PVCOF. So 10,366 minus 10,000. So we got 366. Same way, 16,020 minus 10,000, we got 6,021. Again, 23,560 minus 10,000, which is 13,560. Okay. So we have got NPV for all the three situations. So under the moderate situation, that is when you have a normal scenario without much disturbances, the NPV is around 6,021. However, in the worst condition, you get 366, while during the best times, you get 13,560. However, it is the risk-bearing ability of the investor which will help him to determine whether he can take up this project or not. So we leave it to him to decide whether it should be accepted or not. But however, we give him all the three situations out here in analyzing the project. Hope you enjoyed the solution. Thank you all.